Hello, we are going to talk about properties of functions, and this is the first half of 2.3. Today we're going to talk about something called interval notation. We've talked about set notation, and then we're going to talk about different parts of functions and ways to explain and interpret different parts of a function. And that is your EQ. Right, so let's start with interval notation. So I have some graphs, and we're going to write it in set notation first. It's a little formal, right? We have x such that. And we see for this one, the x value is going from -8 to, okay, I think it meant to be on +8. And just go with that. So we're going in between. We can see that the -8 is filled in, so it's less than or equal to. We can see that on the right side it is open. You have that nice open circle. So it is less than, but not equal to, and we have that. Now if we're going in the other direction about the y, we're looking at it this way, right? So you can see it's going from -3 to 8. So y is such that it's going from -3 and included on the 3 and not included on the 8. Again, open. So interval notation. Interval notation, you have to be careful. It looks like a point, but it is not. And you need to specifically say domain and range. Now in set notation, if you don't put the D and R, it's still clear if it's domain and range because of the X and the Y. The interval notation, you must specify its domain and range. So we can see from from set notation, we're going from -8 to 8. So you are going from -8 to 8. We do not put less than or equal to. There's no X. Again, you have to have the D to tell you its domain. If it's equal to, it is a bracket. If it is less than and not equal to, it is a parentheses. Right? So let's try that on range. So the range, we're going from -3 to 8. Here we have the greater than or equal to, so it's going to be the bracket again. And here's only the less than. So there you are. Okay, very different. So remember, that is less than or equal to. That one is just open. All right, set notation. Now for here, we're going from -8 and we're going this way. And it's going to infinity. It means it never stops. Okay, such that x is greater than or equal to -8. Right? Now then in the range, we're going from this way and we're going down. So it is y is less than or equal to 10. So again, the y's are actually getting smaller, right? It's going this way. Look in these values. So in the interval notation, when you're looking at the set, again, you're starting at -8 and you're going this way forever. So forever means, so you're going from -8 and we're going to positive infinity because that's this way, that direction is positive infinity. Now over here it's closed, right? You have that equal to, so we're talking about the brackets. Now let's talk about infinity. Can you equal infinity? The answer is no. So anytime you have infinity, it will always be a parenthesis. I'm going to say that. If you have infinity, it will always be parentheses. So the range, this time, because you're starting at 10 here, right? And you're going smaller. Now, when you do interval notation, smaller numbers always on the left, bigger numbers on the right. So we're actually going from -infinity, and the biggest number we will get to is 10. Again, small numbers on the left, big numbers on the right, every time. So the 10 is equal to, and infinity, like, because we're going this way, right? It's getting smaller, that's negative infinity. You can't ever equal to negative infinity, because it just gets bigger or smaller. Excuse me. All right, let's try a couple more. All right, try these. Set notation. Again, we're going from here to here along the x. X such that it is between, negative 3, less than or equal to x, less than 2. Again, it was open. The y such that, and y now is going from 5 to 4, both closed, equal to negative 5 less than or equal to 4. Close braces. Right, so the interval notation, we're going from negative 3 to 2, equal to, no. Now for this one, there's both equal to, so it's negative 5 to 4. Okay. Now for the domain, this is a polynomial. You have this nice smooth curve. Continuous, it's going on in both directions, going up, up. So that's our favorite, x, such that x is an element of all real numbers. Now for the range, it's here and it's going up. So y, such that y is greater than or equal to negative 1. Right. So in interval notation, how do you write all real numbers? Well, it's going negative infinity this way, positive infinity that way, and we literally write that. Remember, I'm going to put parentheses on the end because it can never equal to infinity nor negative infinity. For this one, for y, again, we're starting here. This is the lowest number, negative 1, equal to, and it's going up to infinity. It will take time to get interval notation. Just don't mix up the two. See, there's very clear differences with set notation. You have the less than equal to. Interval notation does not have that. So if this was in interval notation, I'm saying that the domain was going from negative 3 to 2, not equal to, not including the endpoints. Again, not a point. All right, increasing, decreasing, constant intervals. And we're writing it in interval notation. So take a moment, if you have highlighters, highlight increasing, decreasing, constant intervals. So it is what it says, like it is. So increasing, when does it go up? And we always read it from left to right. So if I'm looking at this, it's going up this way, right? And this way. Okay. So the y values are increasing. And then if I'm looking at this is going down, but this is going up. This is still going up, flat. And then going down. Okay. Let's go with constant. Oh, decreasing. Okay. Well, that's flat. Decreasing, going down. Down, flat, down. Right. And then a constant. Constant I think of as flat, right? A zero slope because it's not going anywhere. Increasing, you can think of positive slope, though these parts are curved. All right, so let's talk about, going to be in blue, and increasing. So this is where you have to look at the x values, not the y. So if I'm looking at where we shaded, we're just looking at the x values. So that's going from negative 3 to negative 2. So increasing, not a point, it's negative 3 to negative 2, and it's going to be parentheses. Because at a point, if I just had a plain point on a number line, is it increasing, decreasing, or constant? The answer is none of the above. It's only increasing and decreasing depending on the points before it and after it. Since there are none, single point doesn't do anything. All right, so here we're looking at the x values going from 0 to 2. Okay. Decreasing. Decreasing, here again, we're going from 2 to 3, looking at just the x's. Constant, because I put in yellow, I'm going to do orange. Here, again, looking at the x's, we're going from -2 to 0. Okay. You may want to try this one on your own. So even though there's like a little pause here, it's still going up along the whole way. And the x value is from -4 to 0. No, I wouldn't separate them. -4 to -2, the -2 to 0, because it's still all together. Decreasing. Okay, I'm going to go from here to there. Oops, there. -6 to -4. And then 3 to 6. And then this one, 0 to 3. Now, if you look at all these numbers, there should be -6 is where we started from, -4 to here, and then 0, 0 to there, 3, 3, 6. Okay, so there's all the intervals. So you can see that we're talking about functions, different parts of the function. So you can see we're talking about where's the increase and decrease and where's the constant. Another thing about that we talk about, where's its minimums and maximums. Now, you should have discussed this at some point in your math career when you're talking about parabolas, right? This would be a minimum, and then this would be a maximum. So a local is where it is centralized, right? In a little area. We talk about where, just talking about increasing, decreasing, where we go from a maximum is where it goes from increasing to decreasing. So you can see it goes up here, increasing, and then decreasing. Right? Same every time, increasing, decreasing, even for this one. Now for the minimum is the other direction, right? Therefore, it goes from decreasing to increasing. You can see here, it's going down, and right where it changes, it goes up. So that's what we talk about, those local mins and maxes. Now, we think of them as points, and they're points when we're talking about local minimum and maximum. But the book is going to ask you for specifically local value here. It's asking for a value. The value is actually the y value. Right? And I'll show you how to write that. Okay? Now, local max is sometimes called a relative max or relative min. All right, so max, again, changing from increasing to decreasing. Am I looking at that? I can find one here. So we would say, for this function, just going to call it f. At 2, right, x equals 2, there's a max at 6. So we generally write it like this in function notation, knowing that this is the local max value. But we still need to know where the x is of where that is located. So I'm not writing as a point at 2, 6, because that will confuse you with interval notation, so we write it in function notation. So if we're looking for minimums, I'm looking over here. I'm like, okay, I'm going from decreasing to increasing. right? So it's f of, when I put a -3, I come out with a value of -2. Now, are there any more? Here, I'm going decreasing and then go up. You can see that nice dip and then up. So I have another one. You can have more than one. Sometimes you can have none. And there we are. So look at the next one. Okay. So if I'm looking at this, I'm going increasing, flat, constant, going up, and then going down. Okay, increasing to decreasing, so that's 1, f of 2, and then I go down. Oops, sorry, I wrote that wrong. Did you see anywhere, that it was going from decreasing to increasing? I did not see any. And you can't make that assumption over here because we don't know is it going down, is it going up, is it going flat. We can't assume that, so you just do what you see. So I would say there's none for that graph. So that's a local min and max. Now we have something called an absolute, sometimes called global min and max. When you get to calculus, depending on the textbook, and even if you look online, they use different terms. So the absolute max is the highest point on the whole interval, on the whole thing. Again, the value of it is the y value, and the absolute minimum is the lowest point of the whole thing. And you can see how it is written here, again, in your function notation. So the absolute absolute max value is 2, and then here's -2. So just depends on how it's worded, so be careful when you read the book and the problems and how it's worded. So let's look at these. So take a moment, same graph, right? Same graph. Definition is different. So the highest and the lowest point. So if I'm looking here, the lowest point is here. So I'm going to say, which was also a local, sorry, I said that wrong. My bad. A local min. That is now also an absolute min. Sorry, did the wrong one. I'm just going the lowest point. So the absolute can also be a local. Now, if we're looking at a max, the highest point, well, it looks like here, right? Oh, but wait, what do these arrows mean? The arrows mean, yes, we're ignoring the dog, that it is going on forever. So do you see, can you have an absolute max? No, because you're going to say it's infinity. Miss Mendoza, but what if you had infinity plus 1 or infinity times infinity? So there is no, that one has none. It doesn't exist. All right, so what about this one? Take a moment for that as I write this. All right, absolute max. What is the highest value? Okay, I'm going to say this is the highest. There's no arrows. Okay. 2. Lowest minimum is here. Now they're both barking. I'm so sorry, class. All right, so we're almost done anyway. So take a look at this. And here's the summary of them. So if you're looking at this, you can see that there's a local min here. We have that decreasing to increasing. We have the local max here and here. But this one is also absolute because it's the highest out of this whole interval. And this is the lowest point, but it's not local because it's going from decreasing to I don't know. So you can't make that assumption. So it's just the absolute. All right. All right, class, answer the EQ. Until next time, be safe and well. Bye.